Good morning, everybody. On behalf of the project partners, I would like to welcome you to the third day of the second school on smart data processing and systems of Deep Insight. The school is organized in the context of the Destini project and Twinning Horizon 2020 project. Today we will have 6 presentations in total, lasting 40 minutes each. I remind you that the school is being recorded and streamed on Facebook as well. And let's proceed to the first presentation. The first presenter is coming from the Cyprus Institute of Neurology and Genetics. Professor George Spirou, which is the head of bioinformatics department, and the talk is his talk is entitled "Complex Patterns of Biological Information Decoded with Network-Based Bioinformatics." Professor Spirou, you can share your screen, and the floor is yours.
Good morning. Thank you very much for this kind invitation. Congratulations for the organization of this school. I will proceed with my presentation right now. I'm sharing screen, and I believe that you see it in a presentation mode. Is it correct?
Yes, we can see.
Okay. So I will talk about the biological information and the complexity of the data and the patterns that we need to discover and decode by using network-based bioinformatics. And it is all about decomposition and synthesis sometimes, but it is a procedure that it is not only informatics and bioinformatics, but also in other sciences and arts. Like our poet Odysseus said that if you deconstruct Greece, you will in the end see an olive tree, a grapevine, and a boat remain. That is with as much you reconstruct it. So we need to find the best patterns and the best descriptors for something in order to be able to describe it again and reconstruct it in a manner that we can analyze it through a computing procedure in our case. Biology and medicine include many types of information coming from the nucleotide level, genome level, the proteome level with the amino acid sequences, the structural level, because all these molecules, they have 3-dimensional structure. And then we have another level of information that corresponds to the relationship between these molecules and the interactions between them. And going up, we can see that we need to combine all this to stack information that includes all this molecular information. And we have to know also that this data explosion continues, including new single-cell genome sequencing technologies, and also sequencing in various levels, including transcriptomics, epigenomics, proteomics, metabolomics, metagenomics, etc. And another note here is that these omics, most of them, they are time-dependent, and also they are tissue-dependent. So we have temporal variations and spatial variations as well. Above all these data types, we have also data that come from imaging modalities, from microscopy, computer tomography, positron emission tomography, ultrasounds, MRI, etc. And we have a piece of information that comes from the electronic patient record, where we have a combination between structured data and unstructured data that we need to combine. And as we are going deeper in what we have to take into account, we have to remember that we are not alone. We live in an ecosystem, so we have to take care and to account also for interactions with our environment. And so we can take also into account the exposome or something like that. It is obvious that biology and medicine, they are in a big data era. And they are characterized by the 4 V's or now the 5 V's, as IBM has updated this description of the big data. They have the V for volume, because sometimes we are dealing with very large amounts of data. We have the V for velocity, where we are producing very fast this data, and the problem is that we produce in data in a rate much bigger than the rate that we understand this data. So there is a buffering effect here, where we always leave a large piece of information to analyze it later. And this is, there is an effect that we are appending again and again this information, and this creates also a big data of not analyzed information pending to be analyzed. Also, we have this for variety and veracity. Actually, we have many types of information, so there is heterogeneity in the types of information in the biological and medical fields, and there is difference in the uncertainty of the data at the various levels. So we have to take care the various levels of uncertainty depending on the various levels of information that we have. And of course, the 5th V, coming from the value, V for value, is also here for biological data, because we can see that bioinformatics and biological data, they are gaining a large piece of the market, and they have great value nowadays. As biology is transforming to an informatics-like science, also medicine generates a new vision that it is called precision medicine or personalized medicine, or P4 medicine, coming from preventing, participatory, precise medicine, etc. And this is based on the concept that we need to have more accurate information coming from the patient, and multi-level information as well, in order to be able to analyze the standard information coming from the obvious symptoms, the standard tests, drugs that we can have at our disposal, etc., with information from the genomic level, the nutrition level, the physiology level, the description of our microbiome, metagenomics level, etc. And all these data need to be combined together in an integration mode in order to create a profile. This profile is the stepping stone for what is called computer-aided molecular diagnosis. So if we have a good descriptor of the patient or of the citizen, we would like to monitor the health of each citizen. If we have this a good descriptor, a good profiling, then we can provide better estimation, prediction, prognosis, or diagnosis. We have to remember that this profile is not static, it is dynamic. So we have to generate these profiles in a time series in order to be able to monitor the health of the citizen, or the disease progression of the patient, or the effect that a treatment may have in a drug monitoring procedure, for example. On the other hand, as I'm sure that you know already, we have the vision from informatics perspective, where we would like to have or to work in a roadmap that passes from data as a service to information service to knowledge and finally to wisdom, hopefully sometime, in order to be able to help ourselves or to generate a better world. And all these mathematical and computational methods that they can be found in this direction, they can be applied in the biological and medical field, either by using supercomputing facilities, simply workstations, but even also by using our mobiles or cloud platforms as well. In this area, we can hear sometimes the term translational research, and also this characterization also goes to other fields: translational medicine, translational biology, translational bioinformatics, etc. This field, this characterization, translational research, describes a space, a virtual space, where we can, or we need to be able to translate the needs that come from the medicine, the medical part, to the biological part, and also translate the findings from the biology to the medicine in a fast way and effective. So we need scientists that they are in the middle, trying to translate, to bridge this gap between the basic science of biology to the applied science of medicine. And bioinformatics is one of these sciences. Sometimes you can find this term, translational bioinformatics, because this is the concept. They try to translate this finding, to generate methods that will pass fast the findings from biology to medicine, and also the needs from medicine to biology. It is a way to connect the bedside with the bedside. Let's say another term that is a term that we are working on also in our lab is systems bioinformatics, trying to provide in a translational manner methods and tools and analysis, and generate also other questions in a systemic level, trying to combine together the molecules and their interactions and also the various levels of information in order to generate these profiles and finally be able to construct or help or contribute to the computer-aided medicine. In order to do this, of course, we would like to be able to integrate the data, to integrate the omics spectrum, and also go up and include also signal, image analysis, video characteristics, clinical data features, epidemiological, etc., in order to create a profile. And remember, this profile is or should be a dynamic one if we are able to have time points in order to have this temporal variation. A few words of what is a network. Actually, a network is a visualization of relationships among a set of entities. And we have various visualizations or various types, various examples in the molecular level or the biological level of networks. So we may have a gene regulation network where the nodes are genes and the axes represent a directed relationship between these nodes, so it is a regulation, inhibition, activation, etc. Or we may have other types of networks like the protein-protein interaction network, where the nodes are proteins and the edges represent physical interaction between them. So we have an undirected relationship. If protein A interacts with protein B, then protein B also interacts with protein A, etc. But we have also some other more conceptual networks, including disease-to-disease network, where the nodes represent diseases and the edges represent a relationship between these diseases. For example, we may have a disease-to-disease network based on the question on how many common genes to diseases each time do they share. So the edges represent the number of common genes between two diseases each time. Or another question that may generate a network is the question of the number of common phenotypes between two diseases, etc. We may be able to construct a network easily by answering these relationships and putting our answers to an adjacency matrix like the one that we can see here. And we can see that a network may be very simple, like this chain here with A, B, C, D, E, where there's not something interest here, but also the same players, they may change behavior, and sometimes we may be able to reveal interesting topological characteristics like the one below, or where node labeled E becomes central and very, very useful and significant to connect all the other nodes. How can we construct the networks at the biological level? Generally speaking, we can say that we can generate biological networks in two broad categories. The first category is to generate a network based on the evidence that we can find on various databases describing protein-protein interactions, metabolic information, regulation, transcription, etc. But also we can generate networks working on our own experimental data or on high throughput data generated by others, exploiting statistics. So we may have statistically inferred networks based on statistical inference, trying to reveal correlationships between the values that we are measuring in a high throughput omics experiment. So in the first case, we can have the evidence-based molecular networks, retrieving information from databases, trying to read and parse data that come from small, medium, or large-scale experiments, usually aggregated and available in online databases. We may remember here that databases sometimes are quite biased, so we may remember and always use updated databases, central databases, and also try to see whether we can highlight possible biases. For example, we know that in many cases we can find data that are more related to cancer than to other diseases because cancer is over-studied. So we must be careful when we are analyzing and passing information from these databases. On the other side, then the second branch of how we can construct networks, we have the statistically inferred networks, where, for example, here we can have expression data, gene expression data, where we can analyze them and see if there are correlations. For example, in this graph here, we can see that each curve represents a gene, and on the x-axis we have the samples, and on the y-axis we have the expression level. So we can see that there are some genes that they have correlated expression across the samples, or they have anti-correlated expression across the samples. So by applying, for example, a simple Pearson's correlation coefficient analysis, or something like more complex, like the calculation of other statistics, like the mutual information calculation or some entropic measurements, we are able to create again this adjacency matrix, or correlation matrix in this case, where we can find what is the relationship, the statistical relationship of each node against all the others. When we analyze and we generate this type of information, then we are ready to go and to visualize this matrix to a network. And then we can proceed with employing implementing graph theory, statistics, general network science, analytics to analyze the network and to find the hubs, for example, that are the nodes that are multi-connected, or like the red ones here, or the hubs that are bottlenecks. They have so-called high between centrality, the green ones, for example, here, that they are critical to connect modules of connected nodes as well. And of course, we are able to calculate many other characteristics, to perform clustering on the graph, to analyze the distributions of specific groups of nodes, to investigate the density in some region, some regions of the network, to study the connectivity, the robustness of a network, etc. For example, here we may apply methodologies like random walks or other clustering techniques to reveal modules, or create significant reveal significant subnetworks, but they may be related to the condition that we are looking. We can use the so-called yield by association concept, where if we don't know something about a node, then we can find the first neighbors that there are in the network, and then analyze the behavior of the neighbors in order to infer what the behavior of the unknown node could be. We may provide integration approaches to analyze and integrate within each layer and across the layers in order to create this profile that we have discussed earlier. And also to try to find ways to reveal the robustness of the network against an attack. We have also attacks in biological networks, or phenomena that could be modeled as attacks in the network, like mutations or dysregulation of a module, or dysregulation of a pathway, etc. And for example, here you can say a few words in the significance of the topology of the network. If we are able to reveal whether the network is of scale-free topology, meaning that there is a hierarchy where we have very few nodes that they have extremely large degree, and they are called hubs or super hubs, and we have some others that most of the nodes in this network they have low degree. They are not so multi-connected. Then we see that we have structures like this, and degree distribution is something like this. So we understand here that if there is an attack in this network, then depending on the type of the attack, this network will be tolerant or not to the attack. For example, if it is a random attack, then here this network will be robust enough, because in a random mode, it will be not so possible to find the sensitive nodes, that they are the hubs, in order to destroy the network. On the other hand, if the attack is not a random one, but it is an informed one somehow, then this network will be destroyed very easily. So there are many models that allow for studying the types of the attacks and the types of the networks that should be topologically enhanced in order to avoid such types of attacks. Speaking about topology, just to mention that we have three characteristics, types of topologies. The regular network where we have a normality, regularity in the connectivity between the nodes, as you see in the left, and we have also a random network where we have randomness in the selection of the neighbors of each node, but also we have small world networks that this is a topology found to many biological, and not only biological, but also social networks, where they are combining the regular topology with random topology, trying to gain the predictability from the one side, but also to be able to let's say shorten the short paths, the shortest path between each node in order to achieve better and faster information flow. If we have a typical scenario in the analysis, like the one here, where we have multiple sources of omics that we need to analyze, let's say we have the gene expression and microRNAs and drugs related to disease, then we may be able to analyze the genes in a co-expression network, as we discussed a little bit earlier. Also to analyze and find the targets of the microRNAs. These are genes that microRNAs are targeting. Also, we may have drugs and their targets, so we may generate again a network. And then from each network, we may generate genes that are related to the information that we have from each network. And then by going down to this procedure, trying to sort these lists and combine them based on the strategy that we may follow, either by taking the intersection or the union of these lists. If we take the intersection, then we may be more specific, but we may conclude with very few data here. If we take the union, we may take more data, more genes, but we may be less specific. It depends on our strategy. Then from there, when we are combining this information, we may proceed with functional analysis in order to find the pathways, the biochemical functions that are related to this list, and also to try to highlight genes that could be further investigated for acting as biomarkers, combining also information regarding the tissue specificity on the expression of these genes, the abundance, etc., and also to highlight possible drug targets or highlight possible drugs that could be used as a repurposed against the disease that we are looking. What is a repurposed drug? A drug that is made for one indication, and now we are trying to test it or to highlight it in using this for another indication. So this is a change of purpose of the drug, and this procedure is called drug repurposing. I will try to end up with some methods and paradigms from our work. This is a work done on breast cancer gene expression data, where we analyze separately the data that the gene expressions that they are related to specific stages of breast cancer, and we found specific patterns on these networks. And by using these specific patterns per stage, we were able to highlight and reveal some candidate repurposed drugs by also trying to find the targets, the gene targets of these drugs, in order to generate a list of possible candidate drugs to provide this information to the pharmacologists in order to give them some hints on what to use on their new or coming experiments. Or another, let's say, demo of how networks are used in order to find some patterns of information. This is a recently published work on a basic phenotype, fibrosis, where we collected, if I remember well, 13 different fibrotic-related diseases. We collected gene expression data for each one of these diseases. We analyzed separately these gene expressions here. Also, we found the pathways, the biochemical functions that are related to these differentially expressed genes. And also we found also the repurposed drugs that are related to each list of differentially expressed genes. And finally, by taking into account also information regarding chemical diversity and functional relationship of these diseases, in terms that we would like to have drugs that are chemically diverse, to be different in their structure, in order to have representation from various structural families, for example. We try to perform clustering on this space and selecting candidates, representatives from each family. Finally, we concluded, we ended up with some antifibrotic drug candidates and some pathways that are related to the we believe that should be related to the fibrotic mechanism that is behind all these diseases. And we were able to generate very interesting patterns of connection between the diseases. These are the fibrotic diseases, and we can see they are crosstalk depending on the disease similarity based on common overexpressed and underexpressed genes. So by counting the common overexpressed genes between each pair of disease, or the common underexpressed genes between each pair of disease, we were able to generate these networks and understand their crosstalk in this level. Also, we were able to reconstruct disease similarity networks based on the common pathways that they share in a pairwise mode, or the common repurposed drugs that they can share in a pairwise mode. And with this procedure, we may be able to proceed with further drug repurposing. If we find a good connectivity, a meaningful connectivity between two diseases, then we can try the drugs that were made for the first one to try to apply them to the second one, the connected disease as well, in order to see if they could fit as well. Final recent publication that I will have is related to the colon cancer progression, and we studied whether it could be reflected to the monotonicity of the differentiation, the gene expression, and pathway deregulation level. So we took the gene expression profiles and we analyzed them for various stages of colon cancer, and then we kept only the genes that they had only ascending differential expression values or descending, so they were monotonic. And then we related them to the progression of the disease. Further to this, we found also the implicated pathways and the drugs that could be as candidates for repurposing based on this information. So we see here a graph that connects the candidate repurposed drugs with the pathways that they could be related to these drugs. I will stop here. I'd like to thank our group and our group members. They're all excellent scientists. They work hard towards bioinformatics contribution to what is called precision medicine. And I'm open to questions if you would like to ask. Thank you.
Okay, thank you, Professor Spyrou, for this interesting and informative presentation. I will give the chance to the audience if there are any questions, please. Okay, I have a question, Professor Spyrou. Okay, beside the conventional graph analysis that one can apply on a network in order to extract some findings in a network, are you applying any kind of Marlon, what kind of algorithms are you applying in order to extract these patterns that you referred before?
Well, actually, we are working basically on graph theory analytics, and we are trying to reveal the most central nodes by combining either classical centrality measures or measures that they are more complicated in revealing the centrality. Also, we are trying to find patterns that are related to the change of these networks. So we are studying also the so-called rewiring of the network from one stage to the other. And finally, sometimes we end up with standard classification or clustering techniques in order to apply feature selection. So these features, they represent a pattern. Depending on what we are studying and what we are considering as information or as useful information, these features may differ. Sometimes we are working with connected genes or genes that are differentially expressed. Some other times we are working with proteins, etc. But sometimes we are working also with edges. So we can reveal not only the nodes, but also the connectivity between them. We have tried initial effort on working on edges, and now we would like to put also some standard machine learning techniques in order to reveal the best ones from machine learning perspective to see if we can reveal something.
Okay, thank you. And another small question. You said that the transition from one stage to another, this is based on a temporal perspective.
Yes, if we have this information. So we have the progression of the disease. So this is a temporal relationship. Or we have time points where we can measure again and again in various time points the biological status under specific treatment. So we can have a time 0 before giving the drug, a time after 8 hours giving the drug, 16 hours, etc. So we may have a temporal distribution here, and omics that they help us to reconstruct a network for each time point, and then study this change for the network. The difficulty here is to have data, to have proper data from the same patients in order to be more specific. This is not an easy case. So sometimes we are working on an average mode. We are collecting data that describe the stage 1 from one cohort, stage 2 from another cohort, stage 3 from another cohort, hoping that on an average there should be a trend. But this is not so accurate compared to the monitoring of the same individual through the years.
Okay, thank you very much. One last chance for a question, if any. No. Okay, Professor Spirou, thank you very, very much.
Thank you
for your presentation, and we will proceed quickly to the second presentation from Sheraz Aslam. Sheraz is a PhD candidate and a research associate in Cyprus University of Technology. His presentation entitled Enhanced Birth Allocation Using the Cuckoo Search Algorithm. Sheraz, you can share your screen and you can start your presentation.
So, can you see my screen?
Yes, we can see your presentation.
Yeah. Okay. Good morning, everybody. I am Shiraz Aslam, working as a research associate and also a PhD candidate at the Department of Electrical Engineering, Computer Engineering and Informatics, Cyprus University of Technology. Today, I am here to present my recent research work titled Enhanced Birth Allocation Using the Cuckoo Search Algorithm. In this study, basically, I have developed a meta-heuristic based solution to deal with birth allocation problem at the smart ports. So, maritime container terminals play an important role in the maritime industry. They are also known as backbone of any economy, as most of the imports and exports are done with maritime container terminal. The presented figure shows an overview of maritime container terminal. Basically, maritime container terminal has 3 fundamental areas. The first one is seaside area. You can see here the light blue color, and seaside area is primarily responsible to deal with loading and unloading operations of arriving ships. The waiting area is also included in the seaside area. The second one area is marshalling yard area, and this area is primarily responsible to store all the arriving containers, and then the all arriving containers are delivered by land to their required places. And the last one area is landside area. And this area basically connects internal and external transport at the maritime container terminal. So global containerized trade is increasing day by day. For example, in 2018, a global maritime containerized trade was 8.4 billion tons, which was increased in 2019 to 11.1 billion tons. However, lack of efficient berth planning and improper use of port resources at the maritime container terminal increases several problems. For example, accidents at the sea, congestion problem at port, and long waiting times for vessels before optimal berthing, and delays in vessel departures. So, berth allocation is a first and fundamental decision problem at the maritime container terminal, where allocating of available berthing position to arriving ships is known as berth allocation problem. This decision depends on several elements, for example, ship characteristics, terminal characteristics, and several constraints. Ship characteristics includes length of vessel, total load on the vessel, and terminal characteristics include berthing layout. It may be discrete berthing layout or continuous berthing layout. Let me explain next. And the depth of berths, etc. And constraints includes, for example, if any vessel has any preferred berthing position, its requested departure time, or any preferred berthing queue at the terminal. So the presented figure show the timeline of berth allocation problem. So for example, if any ship arrives at point A, and if it starts working at point B, so the difference between point A and B is known as waiting time. It arrives at point A, but starts working at point B. The difference is waiting time. So if it starts working at point B and the requested departure time by vessel companies is at point C, however, it completes its task at point D, the difference between point C and D is known as delay in departure time. So in berth allocation problem, the primary objective, usually the primary objective is to reduce this waiting time and delay in departure time and overall cost of this process. So berth allocation problem has several variants regarding berthing layout and vessel arrival. As for berthing layout, there are three fundamental types: discrete berthing layout, continuous berthing layout, and hybrid berthing layout. In discrete berthing layout, the whole wharf is divided into number of berths, and one berth can be used by only one vessel to perform its loading and unloading operations. You can see here figure A, which shows discrete berthing layout. As for continuous berthing layout, in continuous berthing layout, the whole wharf is not divided into number of berths, and the arriving vessels can be moored anywhere throughout the wharf. You can see here figure B. Regarding hybrid berthing layout, this is a complex type of berthing layout. Here, basically, features of discrete and continuous berthing layout are used. Sometimes single berth can be used by more than one vessels. You can see here in figure C, berth 1. You can see here there are two ships at berth 1, and sometimes a large vessel can use more than one berth. You can see here berth 2 and berth 3 by utilized only ship 3. This is a hybrid berthing layout. As for vessel arrival, there are also two types of vessel arrival: static arrival and dynamic arrival. In static vessels arrival, it is assumed all the vessels are at the terminal before planning horizon. However, in dynamic vessel arrival, there are no vessels at the port before planning horizon. However, the expected time of vessels arrival is known in advance. So in this study, we are dealing with the continuous berthing layout along with dynamic vessel arrivals. So here is some example data for berth allocation problem. To solve berth allocation problem, we are using data like this. The first column is ship number, the second one is ETA, expected time of vessel's arrival. HT is handling time in hours, and ETD is expected time of vessel departure, and PBT is preferred berthing position for vessels, and the last column shows length of ships. So after implementing our scheduler, we will have solution like this. So here each rectangle shows a ship where y dimension is length of vessel and x dimension is total processing time of any vessel. So the fundamental objective of this study is to reduce total processing cost for all vessels by minimizing total waiting time and late departure times. So here is our cost function. The total processing cost of any ship includes three costs: waiting cost, handling cost, late departure, penalty cost. As discussed earlier, the waiting cost is difference between arrival time and berthing time, and it incurs if any ship waits before optimal berthing. The handling cost is cost of total loading and unloading operations, and late departure penalty is added if any ship departs late after then requested departure time. So in this study, we also have added one penalty because of non-optimal berthing position. If any ship has a preferred berthing position and our solution, our proposed method does not assign that preferred berthing position, so a specific penalty is added in total handling cost. So here is objective function of this study, which is to minimize total cost, which includes waiting cost, handling cost, and late departure penalty cost. So here are some constraints of this study. So the constraint one ensures that each ship must be assigned once throughout the planning period. This is a main constraint of the study, which ensures to avoid overlapping of two ships. You can see in this figure, basically this constraint ensures to avoid this situation. For example, ship I is berthing already. If ship J is overlapping in term of maybe time or in term of length of war, so this constraint ensures to avoid this situation at the terminal. So the next constraint ensures that the expected time of vessel arrival must be less than or equal to berthing position, berthing time, which is proposed by our solution. And the last constraint ensures that the berthing position of any ship plus length of ship must be less than or equal to length of wharf. Basically, this constraint ensures to avoid this situation. You can see here, if the berthing position is 800 meter and the length of ship J is 400 meter, so it means it take the position 800 meter to 1200 meter. However, the length of wharf is 1000 meter. So this constraint ensures that this distance 1200 meter is avoided in this situation. So to deal with the aforementioned problem, we have proposed here a meta-heuristic based cuckoo search algorithm. Cuckoo search algorithm is an optimization algorithm which is inspired by the breeding behavior of some cuckoo species, and these cuckoo species usually lay their eggs in the other nests of other host birds, probably from other species. So there are 5 fundamental steps of cuckoo search algorithm. At step 1, generate initial population of n host nest, and then cuckoo lay the egg in the k nest, where k nest is randomly selected, randomly chosen, and cuckoo egg is very similar to the host nest in order to increase the hatching probability. At step 3, compare the fitness of cuckoo egg with the fitness of host egg. Here, fitness means our objective function, which is to minimize a total cost of all the arriving vessels. So if the fitness of cuckoo egg is better than host egg, replace the egg in nest K by cuckoo egg. And the last step, if in order to avoid local optima, this step is added. If host bird notices it, uh, basically if host bird notices the egg of cuckoo, the nest is abandoned and new one is built in order to avoid local optima. There are three fundamental rules for cuckoo search algorithm. The first one is each cuckoo lays only one egg at a time in randomly chosen nest. The second one is the best nest with high quality of eggs. High quality of eggs mean high quality solution will be carried over to the next generation. The egg laid by a cuckoo is discovered by the host bird with a probability of 0 or 1. So here is a cuckoo search algorithm mapping to our formulated problem, birth allocation problem. Here each nest show a solution set which includes birthing time and birthing position. You can see here a nest. If a nest has 2 eggs, it means one egg show birthing position for any sheep, and the second one is show birthing time for any sheep. So if we have, for example, 20 vessels, it means each nest has 40 eggs, because for each vessel we need 2 eggs, one for birthing time and the second for birthing position. And egg shows either a birthing time or birthing position. Cuckoo egg shows a new and better birthing time or birthing position. And total number of host nests is fixed, and which show the total search space of the problem. So here is a experimental setup. In order to validate our proposed cuckoo search algorithm, we are using a realistic data set taken from reference 1, which contains expected time of vessel arrival, handling time, expected time of vessel departure, preferred berthing position for ships, and length of ships. Furthermore, we also have developed random data considering up to 100 vessels. And in this data, which we have taken from reference 1, it contains data for 10 vessels. So as for comparison, we also implemented 2 benchmark approaches, genetic algorithm and mixed integer linear programming. So here is a birth allocation solution proposed by cuckoo search algorithm, genetic algorithm, and mixed integer linear programming. Here, each rectangle represents a ship, and y dimension is vessel length, and x dimension is processing time. Let me explain in the next slide. So, basically, this figure shows waiting time based on previous allocation. For example, if we see vessel number 2, using cuckoo search algorithm, vessel 2 is waiting for 1 hour. However, using genetic algorithm, vessel 2 is waiting for 5 hours, and using mixed integer linear programming, there is no waiting time against vessel 2. Here you can see here vessel 2 is birthed at time slot 11. Time slot 11. And here expected time of arrival is 5. So here it is another important thing to note. We are considering a 30 minutes time interval. We have data for 1 hour time interval. So it means if expected time of arrival is 10th hour, or 5th hour for vessel 2, so it means there are 10th slot. You can see here using cuckoo search algorithm, cuckoo search is allocating birthing time 11 for ship 2, and using genetic algorithm, it is allocating birthing time 15. You can see here, and using mixed integer linear programming, you can see here there is no waiting time, as mixed integer linear programming is allocating birthing time 10 for ship 2. So that's this figure basically explains waiting time based on previous allocation. So from this figure, we can observe that using mixed integer linear programming, there is only one vessel, vessel number 4, which has to wait for only 1 hour. And using the cuckoo search algorithm, there are only 2 ships that need to wait for vessel 2 is for 1 hour and vessel 4 for 2 hours. However, using genetic algorithm, there are maximum ships, which are 5 ships that need to wait for optimal berth allocation, and the maximum waiting time is 5 hours for vessel 2. So we can say that mixed integer linear programming is providing an optimal solution. Of course, mathematical programming languages are always provide optimal solution, and cuckoo search algorithm is providing their optimal solution. As for requested and late departures, you can observe here there is no any vessel which is departed late using mixed integer linear programming. Basically here the last one bar show requested departure time, which is provided by shipping company, and the yellow color shows solution by mixed integer linear programming, red color shows by genetic algorithm, and the blue color shows by cuckoo search algorithm. And you can see here there is no any ship which depart late using mixed integer linear programming and cuckoo search algorithm. However, using genetic algorithm, you can observe here ship number 2 is departing late almost 2 hours, and ship 5 which also departs late almost 1 hour. So we can also observe from this figure. Again, mixed integer linear programming and cuckoo search algorithm are providing optimal solution as compared to genetic algorithm. So here is a comparative analysis when we using random data. Basically, in previous results, we were presenting results from realistic data of 10 vessels. However, here we are presenting results from our random data, which we have generated by uniform distribution, and we have considered here with 10 to 100 vessels. You can see here, again, mixed integer linear programming always provide optimal solution. However, when we compare the total cost of mixed integer linear programming with genetic algorithm and cuckoo search algorithm, the cost of genetic algorithm is high as compared to cuckoo search algorithm. So cuckoo search algorithm always provide near optimal solution. When we increase shifts 10 to 20, 20 to 30, and then we increase 50 to 60 shifts, mixed integer linear programming runs out of memory and it cannot solve the problem considering 60 vessels. However, our cuckoo search algorithm always solve problem and within affordable computational time. So here you can see that if we have considered 60 ships, so the total cost of cuckoo search algorithm is 2102. However, by genetic algorithm 2137. So same for all comparison, and cuckoo search always provide near optimal solution. So here is a conclusion of this study. In this study, we focus on continuous and dynamic berth allocation problem. Meta-heuristic based cuckoo search algorithm is proposed to solve berth allocation problem. As for comparison purpose, genetic algorithm and mixed integer linear programming are implemented. The newly developed cuckoo search algorithm outperforms genetic algorithm in terms of total handling cost. When we compare it with mixed integer linear programming, our proposed cuckoo search algorithm provides a near optimal solution, less than 5% from the optimal at a fraction of the computation time. Furthermore, mixed integer linear programming cannot solve the problem when we consider more than 50 sheets. So we can conclude from this study, meta-heuristic based cuckoo search algorithm always provide best solution in terms of computational time and computational cost, while considering maximum number of arriving vessels. In future, we are planning to consider more complex and more practical problem formulations. For example, we tend to implement berth allocation problem on by considering multiple wharfs as the port of Limassol. We are planning to use real-time data from port of Limassol. Even I started working on this. So we are also planning to consider a hybrid birthing layout, where the birthing layout consider both features from discrete birthing layout and continuous birthing layout. We also plan to consider handling uncertainties because of weathers or maybe because of human interventions. So thank you very much for your attention. So any questions?
Shiraz? Yes, thank you, Shiraz, for your comprehensive presentation. It was quite interesting on a topic that we're not actually aware, but it was very interesting. Okay, if there is any question from the audience, please. Okay, we are on schedule, so I will have a question. Actually, it's a clarification, Shiraz.
Yes, sure.
I'm not sure whether I understood the evaluation project. I mean, the comparison of the results of the Cuckoo algorithm in contrast with the other two algorithms in terms of cost and time. And these data that you are displaying now are coming from the evaluation through the realistic data or the random data? Random data, okay.
Yeah, this is from random data. Basically, we also developed random data based on original data. I mean, okay. We didn't generate randomly length of ship, arriving time. Our random data is also based on original data. For example, you can see here if the minimum length of ship is 128 meters, for example, and the highest ship is 423 meters. So we have developed a length of ship in between 128 and 423 meters. Same like handling time, you can see here if the minimum handling time for any ship is 1 hour and the maximum is 5 hours. So in random data, we have developed handling time in between 1 hour and 5 hours. So we are following all parameters in real.
Okay. Yeah. Please proceed to the next slide, please.
This one?
No. This one. Okay. Yes. This with the chart.
Okay, this one.
Okay. It's time plus the ships. Okay. The purple lines requested departure time.
Yes. Yeah. This is provided by our ships, basically our shipping companies.
Okay. Okay. I'm fine. Okay. Thank you very much.
Okay. Thank you very much.
One last chance for a question from the audience. Okay. Just note everybody that you can contact Shiraz. We will share the contact details of Shiraz and all the presenters. And if anybody wants to make a question, a clarification, or anything, he can contact them on some other time.
Yes.
Well, okay. Thank you very much, Shiraz.
Yeah, thank you very much for providing this nice opportunity to present my work.
You are welcome. Thank you. Okay, we are in front of on the schedule actually, but we can use this time to make our break bigger after the next presentation. If Panayotis is ready, we can proceed with the next presentation.
Hello, Andreas. Hello, everyone.
Good morning, Panayotis.
Yeah, I'm ready. We can proceed.
Okay.
Let me start my video.
Dr. Panayotis Christodoulou is a lecturer at Neapolis University of Paphos and also is a postdoc research associate on sales lab at Cyprus University of Technology, and his presentation entitled Skill Chain and Decentralized Application that Uses Educational Robotics and Blockchain to Disrupt the Educational Process. Okay, Panagiotis, the floor is yours.
Thank you, Andreas, for the introduction. Let me share my, I'm sure that you see my screen, right?
Yes, we can see your screen.
Okay, let me put it as a full screen mode. Okay, hello everyone. As Andreas told before, my name is Panagiotis Christodoulou. I'm a lecturer at the Neapolis University in Paphos and a member of the Destini project. Today I'm going to present you our recent work, which was supported by the Destini project. And basically, we have developed and tested a decentralized application that can be used for educational purposes. Nowadays, there has been a growth demand on the usage of decentralized applications. As you can see this chart, in this chart, the number of unique active wallets that uses decentralized applications is really huge and day by day is increasing. But despite this growth in the development of blockchain applications, the educational sector is a domain that lacks from dApps development. So we have decentralized applications that are being used in finance, in games. We have now the NFTs, the metaverse trends, etc. But actually, we lack from decentralized applications that can be used in different sectors, let's say health, education, etc. So the main purpose of this work was to introduce the blockchain and decentralized applications in different sectors. So what is skills chain? Basically, in this work, we try to bridge the gap that exists between the decentralized applications that are developed for entertainment or financial purposes. Sorry,
Shiraz, please switch off your microphone, please.
Andreas, you can mute it as a host.
Actually, I can't. Maybe Stelios can do this.
Yes, I can do this.
Yeah. So
I will do it now.
Yeah. All right. Thank you. So, as I was telling, basically in this work, we try to bridge the gap that exists between the decentralized applications that are developed for entertainment or financial purposes. So we introduce decentralized applications in a whole new different domain. And to the best of our knowledge, basically the proposed application is one of the first that basically combines blockchain and educational robotics. So what is Skill Chain? Basically, it's a fully deployed Ethereum decentralized application that exploits the capabilities of the blockchain technology. It provides means to educational robotics for securely recording student skills during the educational process. And the overall aim of SkillsCache is to provide an approach for securely exchanging students' records skills, starting from their early years in education, so from their primary schools, etc., and beyond the confines of the academic world. These are the research questions that motivated our study. I forgot to mention that this study was published in the journal Sensors, so it's also in open access, so you can find it through my Scholar profile, and it's publicly available, so you can have a read to the whole text. So the research questions that motivated our study, we are three. First of all, we wanted to examine how blockchain can assist the educational robotics. The second research question was on how can educational robotics securely record student skills during the educational process without the need for the educator or the academic to record those skills on blockchain. And the last research question was on how can students exchange and use their data in higher education and beyond. So imagine that we have a set of skills. We have records for each student from their primary schools. These skills are continuously developed as the children go from class to class, etc. So imagine having a full record of their skills from their primary schools until their university, and then use those records also for career purposes, etc. So that was our main purpose. If we wanted to divide our purpose, basically our purpose is threefold. I mean, from the, let's say, the architecture, the design of that architecture of the actual application. So we wanted to permit the contract owners, which are the educators, first to give access to authorized users. In our case, the authorized users are the educational robots. Then we wanted to allow the authorized users to create or update students' records after the completion of a task or an activity from a specific student. And finally, we wanted to allow students to view, read, and share their skills records with other third parties. This is the main architecture of the skill chain. Firstly, as you can see here, the administrator, which is basically the contract owner, so the person that first deploys the contract on the blockchain network. So the administrator first registers an educational robot on the blockchain by providing the Ethereum's address. So when the transaction is successful, executed on the blockchain, the specific educational robot with the specific address grants access on the smart contract so it can create or update records. Then we have the students. So basically, students, let's say, can perform a task. When the task finalizes, let's say the robot creates a set of values of scores on specific skills. And then the robots basically using the student's address, which is unique. So we are using Ethereum addresses, let's say for cryptography and anonymity of the students. Basically, the educational robot can create, if it's the first time that the specific student performs a task, so at the first time the robot will create a new record for the student. If it's not the first time, then the robot will update the student record. And these all transactions are all recorded on the blockchain. Now, from a student perspective and view, we have the student which can view but cannot modify or alter the skills that were recorded on the blockchain. So the student or the educator, once the skills were recorded on the blockchain, when the transaction was executed from the educational robot, those transactions cannot be altered. So we are not using a centralized technology here, because in a centralized technology, as you know, anyone, let's say the administrator of the database, can go and change the values from the database. Here, not even the administrator, the contract owner, cannot change the values once recorded on the blockchain. So the student can use his or her address to view the skills. He can also share his address with third parties. The smart contract is publicly available, so third parties can go on the specific website where they can search for the skills for a specific student and see the progress of the students during its first year in school, primary schools, and beyond. Now, in order to evaluate the efficiency and efficacy of our application, we created several scenarios, and we ended up with the one that I'm going to present here. So basically, we deployed our smart contract on the Ethereum ring keeping test network. So we use this test network because, as you know, there are high fees in the mainnet of Ethereum. So because this is let's say a tested an alpha version application, we decided to deploy it on the Ethereum ring keeping test network. The list of transactions as well as the source code can be found on the specific smart contract address. So if you click here, I'm going to be able to see all the transactions that happen on the smart contract as well as the source code. Also on the published paper, there is a GitHub repository as well as the link where you can see the source code. Now, in order to evaluate the efficiency of our application, we first deployed the smart contract. So we created a wallet. We connected on the Ethereum ring keeping test network, and we deployed the smart contract. So the address that deployed the smart contract is basically the contract owner who acts as the administrator of the decentralized application and has this specific address here. Then we generated an Ethereum address for a specific robot, and the administrator of the system registered that specific address for the specific robot on the blockchain. So basically, the educator granted access to the educational robot in order for the educational robot to interact with the smart contract. So only Ethereum addresses that have access on the smart contract can basically create or update records. Then we generated an Ethereum address for a specific student, and that Ethereum address was used in our use case. Later, we asked from the student to perform the specific activity given by the educational robot. And at the end of the task, the robot generated some scores for a set of skills, and those skills were sent and recorded on the smart contract for the specific robot. We have a table where we can see what was recorded on the blockchain. So basically, we have the student address, and for that specific student address, because it was the first time that he created the record, we have the specific skills that were recorded that basically first were calculated from the robot, generated from the robot, and then recorded to the blockchain. So basically here we were asking the student to do, let's say, some mathematical equations and basically communicate with the robot with the correct answers, etc. Now, besides, let's say, the transactions that basically, the functions that basically you write on the smart contract, we have also the read functions. In order to evaluate the read functions from the smart contract, we use the environment of an online Web3 application. As you can see here, we went to a website in a blockchain explorer. We found our smart contract. Then we called the search student skills function using the Ethereum address of the specific student, and we got back the correct data. So here, basically, we evaluated that the data are recording successfully on the blockchain. Here we have some discussions on timing and the fees. So basically, in order to call core functions of the smart contract, basically it needs some time. So in the centralized, let's say, applications, these functions basically when called are performed more quickly than function of the blockchain, because here we have the block verification. So when we make a transaction on the blockchain, basically that transaction needs to be picked up from a miner and then insert it to a block. And once the block is verified, basically, then the data are successfully recorded on the blockchain. And this needs some time. The average execution time for the allocator function was around 6 seconds. For the add student skills, so this function is called from the robot when the robot wants to, let's say, record the student skills on the blockchain. The average execution time was 10 seconds. Now for the read functions, so when we want to search the student skills, basically, because here there is no need to write on the blockchain, but basically we're using the blockchain, the smart contracts to read from there. So basically the average execution time is less than 1 second. So this happens as any other centralized application in some milliseconds. Now, regards to the cost, because if you want to deploy a smart contract on the blockchain, or you want to record some data on the blockchain, there are some costs. Now, for the contract deployment, the average cost is around $2. Basically, in the Ethereum network, there is a calculation that uses the gas limit and the transaction fee in order to calculate the transaction fee of the deployments or when calling core functions. The fees here basically were calculated based on the current Ethereum value on that day, which was less than today. So imagine the time that time by time that the Ethereum value increases, those transaction fees will also be a bit more. Now, for the allocator function, there is a transaction fee of 0.13 USD. So if we have, let's say, 5 robots, then we will need, let's say, around less than $1 to register all those robots on the blockchain. For the student skills function, there is an average cost of 60, let's say, cents in dollars. So if we have many students, imagine that this cost would be high. That's why in our future work, as I will explain later, we want to deploy this application in another Ethereum EVM compatible network that has lower fees. So basically, here is some part of our future work that we're currently working on. First of all, due to the fact that in the proposed architecture, the core components are not directly linked, human effort is partially required. So let's say first the educator needs to register the robot, and then as the application is right now, once let's say the skills are generated from the robot for specific students, there is, let's say, a little human effort that is required to be written on the blockchain. In the future, we aim to fully automate the proposed solution by utilizing computer vision techniques. So basically, we want also to combine computer vision with educational robotics and blockchain. So the computer vision techniques will be used to verify the student automatically from the robot instead, let's say, from the educator. And lastly, basically, we want to deploy the decentralized applications in different EVM compatible networks, like Matic, Binance Smart Chain, Moonriver, etc., and compare how the proposed application performs on those networks, and create, let's say, a new user study that basically we will compare timing and fees in order to identify which network is better, let's say, to build more special purpose applications rather than entertainment or financial applications. Thanks for your attention. It was a short presentation. The full paper can be found online. I will also share it, Andreas, with our participants.
Thank you very much, Panayotis.
Also, our group and Destiny project and our group, the Sales Lab in Cyprus University of Technology, is open to collaboration with any other field that wants to examine the blockchain technology and identify if there is some space to improve its current, let's say, infrastructure. Thanks, Andreas.
Thank you very much, Panayotis. Now I will give the chance to the audience to place any questions that may have. Anybody?
I have a small question. Could the skills not be standard and be dynamically for each student?
Basically, the set of skills as the smart contract was, let's say, designed, has a prefixed number of skills. The numbers of skills, let's say, we are taken from another study of Salome et al., which made a comprehensive study on which skills are developed using educational robots. So we use the study, we identify the skills from the study, and we use that in our application. Now, regards to the scores are not changing. Basically, from the robot can be changing dynamically, but at the end of the day, once the task is performed, then let's say the last scores will be recorded on the blockchain. But when the student continues to perform tasks, those skills are updated continuously until, let's say, the end of all tasks.
Okay, thank you.
Thank you.
Okay. Anyone else? A question to Panayotis?
Yes, Andrea?
I have a general question, let's say. Panayotis, anyone can understand what are the benefits one can get from such a approach. I mean, to develop a decentralized application using a blockchain technology. But I want to have your what you think about how this approach affects the development process in terms of the cost, in terms of reliability, then deployment type, and maybe the performance, and how this approach, this blockchain technology approach, you think will reshape the way we are approaching the software engineering process and all related aspects, let's say.
Thanks, Andrea, for the question. First of all, we all know that some Ethereum, some blockchain networks have a high cost, and these high costs basically are because of their high value today. So imagine in Ethereum that the formula for calculating gas cost and gas fee on the Ethereum network that was created back in 2015-16 is still the same today, but by that time Ethereum was just some dollars, and now it's some thousands. So because it's the same kind of formula, that's why there are high costs. But if you compare, let's say, the infrastructure that is needed for cloud applications, etc., in general, not in general, let's say in 1 year, let's say, and the costs that are needed, but it's also based on the volume of your decentralized applications, you can find, let's say, that is more less to host, let's say, an application on a decentralized network. I'm not speaking about Ethereum because Ethereum is expensive, But nowadays there are several networks that are EVM compatible that has nearly zero fees. So you can use this, let's say, that in decentralized networks for the development of your decentralized application. So because at the end of the day, the user, let's say, does not really care on which network he's interacting with, but he sees the main, let's say, application that is decentralized is more secure and safe. Now, in terms of the security, let's say, the network is secure, but because smart contracts are basically lines of code, so if you developed and code, let's say, a poor application in terms of coding with bugs, etc., then obviously your decentralized application will have also bugs. There were several hacks, especially in DeFi applications, decentralized finance applications, in the past, due to poor code, because at the end of the day, everything is code. Now, we are living in the era of Web3. So imagine in the 90s, we have the Web 1, where we are logging with a username and password. During Web 2, and the explosion of and the growth, of the social medias, we also logging with Facebook, logging with Twitter, etc., etc. Now we are living in the era of Web3 applications, where basically you can use a wallet to perform actions on specific applications. And imagine that, imagine that wallet that you are using, that address that you are using, which is basically your username, can also be a bank account. So this is the transformation that we are living right now. During the Web3, we have addresses which can be used in decentralized applications, and at the same time, those addresses are bank accounts. We are, especially me, because I'm in the blockchain, let's say, space, I'm really excited of what is happening. Every day we see huge corporations to develop, because it's harder for them to transform their already developed applications as Web3, but when they are building new applications, they are thinking in a more different way, Andreas. So in the software engineering, as we told before, we're thinking as object-oriented, let's say, techniques. And now, basically, we have to think not only as object-oriented, but also as Web3, let's say, oriented techniques. So in the near future, I'm also sure that the whole software engineering will reshape with new techniques regards to Web3 applications.
Okay, thank you very much for your answer, Panagiotis, and also for the presentation. If anybody from the audience have one last question, I'll make it now. Okay, we can close this session. We are in front of our time, of our schedule, but we will have a long break now before the opening of the new session and the fourth presentation. We will have a break and we will be back at 11:10. Thank you all.
Hello, everybody. Just talk to the next presenter. There seems to be some sort of misunderstanding. George thought his talk would be tomorrow. So we can move to the next presentation if the next presenter is ready. Let me check. Andreas, the next presenter is
Flavia Monti and Jerin George Matthew.
Yes.
I can see them connected.
Yes.
Can you please move forward with your presentation so that we cover for the gap of this misunderstanding?
Yes, sure.
Okay, perfect. Thank you.
Just let me share my screen
Andreas, you have the organization again. Thank you.
Thank you, Andreas. Guys, just let me to introduce you. Jerin, George Matthew, and Flavia Monti are coming from Sapienza Universidad di Roma, and they will present. They will make a presentation entitled "Transformation in Traditional Industry, Die Cutter 4.0." Guys, the floor is yours.
Thank you. Thank you for the introduction. Hi, everyone. I'm Jerin George Matthew. I'm with my colleague, Flavia Monti. We are two PhD students at Sapienza University, and we'll talk about transformation in traditional industry, Die Cutter 4.0, which is a case study on a company named Rota Laser. So you might have heard about terms like smart manufacturing, digital factory, and Industry 4.0. And all of them refer to a sort of, let's say, natural evolution in the manufacturing process, where several cutting-edge technologies like Internet of Things and cloud computing are jointly applied in the manufacturing process to improve productivity while reducing costs. And here's a picture showing how the manufacturing process changed over time. And it all started in the 18th century with the first industrial revolution, where steam power was first leveraged to improve productivity. Then we had the second industrial revolution, during which electricity was discovered and assembly lines were first developed in the manufacturing process. And then we had Industry 3.0, where computer chips were used to automate production with few or no human intervention. And right now we are in the middle of the fourth industrial revolution, where Internet of Things and cyber-physical systems are employed to advance even further the manufacturing process. And indeed, equipments inside factories are strongly interconnected and closely monitored. And data coming from those machines are collected and used to improve even more efficiency and quality. And in a sense, the main idea here is to enable equipments to sort of reason about themselves and adapt to changes like breakdowns. And we expect that this in turn will improve production efficiency, decrease manufacturing costs, and all of this while easing workers' lives. So in this context, a key part of any digital factory is the maintenance strategy, since it takes a significant amount of time of the overall cost of a company. And maintenance strategies revolve around how a factory should react to prevent machine failures and mitigate downtime. And the main challenge here is to guess when a machine should be replaced or should be repaired or should be replaced. And there are plenty of maintenance strategies out there, which can be mainly organized into 4 classes. So we have reactive strategies, which is something like run to failure. That is, you use the equipment until it breaks down. And this strategy is only beneficial, however, up to the point where the asset fails, since the cost of repairing the asset may, after failure, can potentially be more than the production value received by running it to failure. Then we have planned strategies where maintenance activities are scheduled while the equipment is under normal operation to avoid unexpected breakdowns. And while planned maintenance may be more cost-effective than reactive strategies, it can also be more difficult to justify, since parts may be replaced while they have still useful lifespan remaining, and organizations must keep spare parts on hand. Then we have proactive strategies where critical parts of the equipment are improved and enhanced to delay future breakdowns. And finally, we have predictive maintenance, where the equipment is continuously monitored to predict future breakdowns. And this in turn requires proper hardware and software infrastructure built on top of the equipment, and this may not be a trivial task. And in this sense, Industry 4.0 and smart factories may bring a wider adoption of predictive maintenance strategies. So here we'll talk about a case study of a factory that has undergone this transformation. More precisely, we'll talk about Rotalaser, which is an Italian leading company with 30 years of experience in manufacturing high-quality die cutters. We'll talk about die cutters in a moment, but you can think of them as a building block of an equipment called die machine, which is used in box factories to cut shapes out of raw cardboards. So what is a die cutter? You can think of it as a wooden board with a set of blades and rubber tips on top of it. And as we said before, the die cutter is mounted on top of an equipment called die machine to cut shapes out of paper. And each die cutter features a set of different blades like cut blades, crease blades, cut crease blades, perforator blades, which are mainly used to properly cut the cardboard, producing folds, punching holes into it, and so on. And here the rightmost image shows a set of die cutters in a box factory, while the left one shows a close-up view of blades inside a die cutter. And rubber tips inside the die cutter are used to remove cardboard trimmings. And both blades and rubber tips are placed into a die machine according to a cut file, which contains details of a cardboard like its shape, its size, and other details. And we talked about before about die machines, and we have two main types of die machines, which are rotary die machines and plane die machines. So accordingly, we have two types of die cutters, which are rotary die cutters and plane ones. And the rightmost figure shows a rotary die cutter, which is a slightly curved board, while plane die cutters are flat. So here's a sketch of how a rotary die cutter works. So there's a rotary die machine, which you can think of as two big rolling drums, and the die cutter is this wooden board placed on top of one of those rolling drums. Then we have a conveyor belt, which continuously feeds the die machine with raw cardboards. And as cardboards are fed into the die machine, the die cutter passes through each of them in order to make cut-out cardboards. And here's a video we took inside a box factory. So here's a batch of cut-out cardboards, and then going towards the die machine. Here's the conveyor belt with cut-out cardboards. Here is it. And then going backward, we have the die machine with a rolling die machine with a die cutter on top of it. So, okay. So here's a typical interaction between Rotalaser and a customer. And this describes the life cycle, a typical life cycle of a die cutter. So it all starts with a box factory requiring a set of die cutters to produce cardboards, and details of the cardboard are included in a CAD file that the box factory provides to Rotalaser. And at this point, Rotalaser will start producing one or more die cutters, and this may require a good amount of time. And when the die cutters are ready, they are shipped to the customer, which uses them to make cardboards. But over time, die cutters may wear out, and in such cases, the box factory will halt its production and will ask Rotalaser to either repair or replace the die cutter. And finally, Rotalaser will either repair or replace the die cutter and ship back it to the customer. And again, this last step may take a significant amount of time. So as we said before, die cutters may break down since blades and rubber tips on top of it may wear out. And employees of a box factory may notice this since such faults will introduce some kind of defects when producing cardboards. So here's an example of a faulty cardboard, namely missing all into it due to a broken die cutter. And the main problem here is that there's no way to tell if a blade or a rubber tip is wear out since without a manual inspection by employees. Also, since employees can't inspect cardboards all the time, there's a delay between the fault and its detection. So cardboard defects are usually not spotted in time. And when a fault in a die cutter occurs, employees have to recollect cardboards made by such die cutter and discard those with manufacturing defects. And this in turn slows down the production and is a clear waste of time and raw materials. However, repairing or replacing or building a new die cutter is not a trivial task and may require a good amount of time. And at the moment, Rotalaser has no way to predict when a die cutter will break, since so many factors comes into play, like the number of cardboards produced by the die machine, or the average rotation speed of the die machine, or temperature and humidity inside the box factory, and so on. So there's no way to predict when a fault may occur, and this in turn makes future maintenance activities unpredictable. And clearly there's an advantage in predicting when a die cutter will break down, both for Rotalaser and its customers. In fact, box factories may minimize idle times in cardboard production, since they can preemptively ask Rotalaser for a brand new die cutter. And on the other hand, Rotalaser may schedule a proper maintenance strategy based on the usage of its die cutters. But however, to accomplish this result, a continuous monitoring system of die cutter usage is required. So Sapienza University started collaborating with Rotalaser to address the problem of monitoring die cutter usage. And we ended up developing Die Cutter 4.0, which is a fully fledged monitoring system for die cutters. And it revolves around tracking usage data of die cutters like rotation speed, temperature, humidity, and cardboard production quality to assess the overall health of a die cutter. And this in turn helps Rotalaser and box factories to assess when a fault may occur and when the die cutter should be replaced. And our solution is can be broken down into two parts. So we have on one side a Bluetooth low energy beacon named RubyTag, and then an industrial camera, high resolution camera. The RubyTag is placed into each die cutter and keeps track of working parameters like the rotation speed, temperature, humidity, and so on, while the high resolution camera is mounted on top of the conveyor belt and checks for cardboard defects during the production process. So we started off a pilot project with a box factory owned by Rotalaser, by International Paper, which is a customer for Rotalaser. International Paper is an American paper company that spans several countries, including Italy. And one of those plants was part of our pilot. So we picked a single die machine inside one of those plants of International Paper as a starting point, and we set up all the required equipments. And specifically, we set up a high-resolution camera over the conveyor belt to capture and monitor cardboards made by such die machine. And we also put 4 tube lights to improve the brightness of frames captured by the camera. And then we took 8 die cutters in the box factory and put a Ruby tag inside each of them. And finally, a mini PC was placed in near the die machine to collect data coming from both the Ruby tags and the high-resolution camera. Now, Flavio will talk about the pilot project in more details.
Okay, so can you hear me?
Yes, we can hear you.
Okay, so how does all the system work? Let's say we have a die machine on top of which we installed one of our die cutter equipped with a Ruby tag. And at some point, this machine starts rotating, so it starts producing cardboards. This is where the Ruby tag beacon comes into play, because it will start sensing this rotation, and it will start sending the Bluetooth messages to the local mini PC. So these Bluetooth messages notify that the machine is rotating, thus the die cutter is starting his session. At the same time, the local mini PC runs a C# application to scan all the messages coming from the Ruby tag. And these packets are parsed in order to collect all the information contained to it. At that moment, so when the mini PC received the message of starting a session of a die cutter, it starts streaming the camera. So all the frames collected by the camera are captured, and the cardboard passing over the conveyor belt are collected. Data collected from both from the Ruby tag and from the camera are stored in the mini PC in a time series database, and it is periodically transferred to a central server owned by Rotalaser. The local PC also runs a dashboard which helps the workers and the employees in the box factory to keep track of the die cutter health status. Okay. This is the worker dashboard that contains different information such as rotation per minute and different error stats about the errors detected from cardboard. This is a picture describing the overall architecture of the big systems that we develop. Suppose we have n box factories. Each of them may be equipped with, each of them contains different die machines. And these machines are equipped with an industrial camera and a local PC and all the other equipment that we need for our system. All the die cutter produced by Rotalaser will contain the built-in beacon Bluetooth. So when the die cutter runs in each die machine and all the different box factories, all the data collected by the local mini PC will be transferred to the central server of Rotalaser that will process this data to provide all the useful insights to both Rotalaser and its customer, its box factory's customer. Okay, a key part of our architecture is the Bluetooth low energy beacon that we put on the die cutter. Right here, you can see an image that shows a close-up view of the die cutter with a Ruby tag installed. We did a hole inside the die cutter to contain the Ruby tag sensor. And we locked it with a high grip scotch to prevent it to fly away during the high speed rotation of the roller during the production of cardboard. As you can see from the images, the Rubitag sensor is a small and thin environmental sensor that is able to keep track of different aspects like temperature, humidity, pressure, and motion by using its accelerometer. These sensors are shipped with a battery that lasts from 1 to 3 years. And this is very important to notice because we expect the battery to last as long as the die cutter. Indeed, replacing a Rubitag when their battery runs out will be a very big problem. Each Rubitag is also equipped with a custom firmware that we developed with the purpose of collecting additional parameters, additional variables than the default one. These variables are the rotation count and the rotation speed. And thanks to these additional variables, we are able to recognize when the die cutter is in session or not. And we let the Rubitag to send Bluetooth messages only during the die cutter session. So these save its battery. In order to compute those additional parameters, we leverage the built-in accelerometer. In fact, each Rubitag has a high-frequency multi-axis accelerometer, and for that reason, we installed the Rubitag on the die cutter in a specific way. The sensors are placed into the die cutter such that one of those accelerometer axes is orthogonal with respect to the rotation axis of the die machine. And what we expect is that samples of this signal from one of the axes form a sort of sine wave that reflect the rotating die machine. The accelerometer values are collected from one of the three axes and they are preprocessed. A Fourier transform is performed in order to get the rotation frequency of the die machine. Both this rotation frequency and its amplitude are used to determine whether a die machine is actually running and rotating or not. And based on this information, as said before, the Bluetooth messages are then sent to the local mini PC. The other key part of our architecture is related to the detection of defective cardboards. To capture cardboards passing at high speed over the conveyor belt, what we need is a camera able to capture high quality images at a high frame rate. And for that reason, we choose to use an industrial camera named Pixelink that satisfies all our requirements. We also use a personalized 3D print case to protect the camera from dust, and 4 industrial LED lights to light the scene in order to acquire brighter images. A tailor-made structure we use to mount it over the conveyor belt to hold all the stuff that we use. Okay, this figure explains the high-level pipeline of how the process of discovering defective cardboard is done. The defective cardboards are found comparing capture frame by the camera with the CAD reference file. The CAD reference file is an important part. It is a file that contains all the specification of how a particular decutter is, and information coming from that file, like cardboard shape, cardboard dimension, and more important, the location of all the cardboard feature, are used as a ground truth to check the produced cardboard. So a comparison is done between this information and the information extracted from capture frame. So when the mini PC receive the messages of a decutter that start its session, it starts streaming the camera, and a Python program continually grab the frames and process them, applying many image processing techniques. These techniques are, for example, mask extraction, morphology operation, pixel value analysis, perspective correction, contour funding, and so on. An important pre-processing phase is implemented before analyzing the image of cardboards. And this is needed because the capture frame by the camera do not contain the entire cardboard. So different merging techniques are used to construct an image containing the entire cardboard. Then the cardboard is manipulated to extract all the information that are then compared, as said before, with the CAD reference information. Here on the right, you can see a representation of the DXF CAD file. This type of files are structured in layers. Each of these layers contains all the details about the different blades contained in the decutter. And what is of our interest is the right side of the image, because it contains a clear representation of the cardboard shape. So we develop a Python program to extract all the important information in that part of the file that are needed to compute the errors in the cardboard. The errors that can be found in a cardboard production are many, and two of them are those related to holes and folds. So those produced by the cut blades and crease blades. Cardboard holes are found by analyzing the cardboard mask. A mask is a binary image, so an image containing 0, 1 pixels. And specifically, a cardboard mask is an image where cardboard is white color, while the background is black colored. To construct the cardboard mask, the in-range function was used, and it was applied over the red channel of the image. And once the cardboard mask is extracted, all the contours related to the holes inside the cardboard and the external contour of the cardboard are found. The bounding boxes are computed related to all the detected objects, and their location and dimension are used and are compared to the CAD reference information. In these images, you can see a cardboard mask and a cardboard containing the bounding boxes of all the holes identified. We can notice that this cardboard presents a missing hole, and This is why it is not recognized by the contour funding, so the bounding box was not highlighted. To find the defaults on the cardboard, the image is first converted in HSV space, and the value channel is inspected. All the values of the pixel intensity in each row and column of the image are analyzed to find the local minima. In fact, we notice that at a fold, there is a variation of intensity of the pixels, and the local minimum corresponds exactly to where the fold is located. So all the points found related to this local minima are approximated to straight lines by using the Ramsack algorithm. And same as before, they are compared to the CAD reference information. Finally, all the detected errors are annotated and are highlighted in an image that is stored in a cloud. All data related to die cutter usage collected by the RubyTag and those related to the detected errors are stored in a time series database in FlexDB in the local mini PC. A Python program is responsible to collect all this data and use the MQTT protocol to send them to the Rotalaser cloud that collect all the data. On top of the server, we developed a dashboard to let both Rotalaser and its customer to view the die cutter usage data. These views are those related to real-time data, historical data, and also images of faulty cardboards. So the customer, the box factories, are able to manipulate the cutter their own, and they can see every information about them, like for example the number of produced cardboards, rotation speed, temperature, and all the other variables collected by the RubyTag sensors, and also the errors related to a specific die cutter session with the related images can be seen. Okay, this is a small demo of this die cutter, of this dashboard. A login screen enables customers and Rotalaser to access the cardboards, the dashboards. The home page shows a list of box factories, and by clicking on one of them, all the die cutters are shown. Each die cutter has a label indicating if it is working in that specific moment or not. And there are also different buttons to access all the historical data and the real-time data. This other demo shows the real-time data screen. We can see different charts related to rotation count, rotation speed, temperature, and humidity. And on the bottom, you see that there are all the errors identified in each session, and all the frames can be seen. So to recap, we have seen the recent trends in the manufacturing world, in which the smart factoring drives the fourth industrial revolution. In this context, we presented the Rotalaser company's case study with their die cutter that have undergone this transformation. We have seen how the Bluetooth low energy beacons and image processing techniques can be used to help Rotalaser and its customer to keep track all the health status of the die cutter. And to conclude, we want to underline and notice the benefits that comes to to both rotalaser and box factories. In fact, rotalaser can closely monitor its die cutter and provide branded new ones to its customer when they are needed. Collected data are also collected from all the box factories and may be used to design better maintenance strategies. For instance, data can be used to train a machine learning model which predict when a die cutter may break down. And finally, collected data may also be used to provide new services to customer and improve its sales. On the other hand, box factories, so customer of rotalaser, can minimize idle time in cardboard production, since broken die cutters are readily replaced when they broke down. And they also can leverage those additional services to monitor its production and find all the manufacturing defects. Okay, thanks for your attention. We hope you enjoy it.
Yes, thank you very much, guys. Your presentation were quite interesting with an applied research case study. Now I will ask the audience if there are any questions.
I have a question.
Yes, Taylor, please.
So your case study where you are using the platform to monitor the die cutters could be expressed as a digital twin. Is that true?
Yeah.
Okay.
Because
that's my question.
It is like a representation of how the system is working in that moment. So we monitor exactly what the machine is doing in real time.
Thank you very much.
Okay. Also, guys, I have a question for you. I'm a little bit confused. I will kindly ask you to make clear whether your approach falls in the reactive or predictive maintenance strategies. I'm completely confused about this issue. And the second question is whether you evaluate somehow your approach by comparing it with other strategies, maybe, or other approach. Thank you.
So the idea here is to use this data to train a predictive model to make maintenance strategies that is more closely related to predictive maintenance strategies. But we are still working on how or proper ways to predict faults when we use a die cutter. So that is still an ongoing work, but we frame it as a predictive maintenance strategy. So that's okay. our end goal.
What about evaluation or maybe a comparison with other approaches?
Since this is a pilot project, we are still working and it's not finalized. So we are still evaluating it. So this we're still working on it.
Okay, understand. Completely understand. Okay, if there is no any other question from the audience, we can keep up with the next presentation. Guys, thank you very, very much.
Thank you
for your positive response and your presentation.
Thank you.
Thank you.
You're welcome. Okay. Due to the problem we had with the first presentation of the second session, and we skipped this presentation, we are now ready to proceed with the next presentation that is coming from by Professor George Botsaris. Hello, George.
Hello, can you hear me?
Yes, I can hear you and can see
you
your
screen? Yes.
Yes, your screen. Professor Botsaris is coming from Department of Agricultural Science, Biotechnology, and Food Science from Cyprus University of Technology. And George, when you are ready, the floor is yours. You can start your presentation.
Thank you very much. My presentation will be a bit different. It will be a bit more biological, and we will see how we use, we can apply data basically to interpret the results we get from the research we carry out in the area of bacteriophage for detecting and biologically controlling foodborne pathogens. And we will look at the case of Mycobacterium avium subspecies Paradospeculosis. So we'll do a small introduction to see what this microorganism is, and we will just call it MAP, Mycobacterium avium subspecies Paradospeculosis. We will look at the current detection methods and their limitations, and then I will describe the combined phage PCR detection method we developed, and we will see the results we have from a Cyprus raw milk survey we carried out, and examine the potential of biological control, and then we'll draw our conclusions. So first, MAP is basically a rod-shaped bacterium, 1 to 2 micrometers in length, non-motile and acid-fast, and has been identified as the causative agent of Jaundice disease in cattle. Jaundice disease basically is a chronic debilitating enteritis of cattle and other ruminants. And we know that during the disease progressions in cattle, MAP is shed into the milk of the infected animal. And we know that it can live in the intestines of cows asymptomatically for long periods of time, and this makes herd eradication very difficult. So MAP in the human chain, it can be present in milk and can be consumed by humans. The FSA in the UK reports 2% of retail milk is contaminated with MAP, and MAP has long been suspected to be a causative agent, a contributing agent in the development of Crohn's disease in humans, therefore posing a potential risk to human health. The FSA in the UK has therefore developed a long-term strategy to introduce measures to stop MAP at source, and there is a need basically to detect fast this pathogen. Currently, the detection methods for these pathogens can be divided in 3 major categories. The first one is the culture-based methods, which in this case are very slow because it requires 3 months to grow the reference strains. So it takes a lot of time, and because of this very long incubation, which is required, as a decontamination step is also needed, which destroys a number of viable cells, MAP viable cells as well, therefore reducing the sensitivity of the method. The immunological tests are applied, ELISA-based detection. These are not very sensitive as they can present cross reactions with other species. And the molecular methods. Now, the molecular methods are very good. Our method is molecularly based, but if we apply molecular methods directly in food microbiology, they have a major drawback, which is the detection of both live and dead cell. If a cell is destroyed, we will detect its DNA, but it will not be infective. So we need to differentiate, especially in processed food, live and dead cells. So we use bacteriophage to do this differentiation. And basically bacteriophage are bacterial viruses. They are viruses that infect bacteria. Why do we use this bacteriophage detection? Because it's fast. We can get results in less than 24 hours compared with 3 months we need for the culture. They are reliable. They are cost efficient. The test, once it's set up, is relatively easy to perform, and there is no need to contaminate our samples. Therefore, we have increased sensitivity. And we detect only viable cells because dead cells cannot be detected as in the case of other molecular PCR-based methods. The first thing we do before we process a milk sample is we have to concentrate it to increase our sensitivity. This involves a series of centrifugation steps. We get the pellet, which we wash and resuspend in an attempt to increase basically our sensitivity. The phage assay itself, it involves the contamination of the sample we have with the phage. So we add the phage, we incubate and we allow time for absorption to take place. And once the phage is absorbed, then we add a virusite to destroy the non-adsorbed, the exogenous phage. And we allow some time for incubation, which is only 5 minutes. The virusite we are using is ferrous sulfate. It's not something that it will destroy the cell. And then we neutralize this virusite by adding more buffer to our sample. And then we add sensor cells, which are environmental species of Mycobacterium smegmatis. We use it as a sensor cell. And we know that at the end of the assay, we will get on our Petri dish a positive indication will be the formation of plaques, of no growth areas. So we know that in the center of each plaque, we have a copy of the initial target cell genome. And this is what we target to verify the presence of the pathogen we are looking for, in our case, MAP. So we did a survey to validate our assay, and we took samples from all the 225 at the time registered dairy farms in Cyprus. You can see the map here of the area effectively controlled by the Republic of Cyprus and the locations of the farm we sampled. And we were getting one sample was processed through the phage amplification assay. We also carried out a total viable count on our samples to see the total number of aerobic organisms we had in our sample. And we also performed the classic culture for Mycobacterium paratopegulosis, which was culture of yellow egg yolk medium on the classic slants we use. So at the end of the assay, at the survey, what we got from the 225 samples we analyzed, 218 samples, these are raw milk samples before processing, we are positive for Mycobacteria. And they gave numbers from as low as 2, the positive ones, to as high as 320. So what we did then is we did the PCRs to identify which of those, because there are over 120 different species in the Mycobacteria genome. We wanted to know how many of these were mapped. 50 of them, a percentage of 22.2%, were identified with IS900 PCR as positive, whereas the remaining 175 were negative. And we can see here the results we were getting from the analysis. The culture, on the other hand, from the culture, we were able to identify 26 samples as Mycobacteria positive with Ziehl-Nielsen staining, which is a staining technique we use to differentiate Mycobacteria from other bacteria. And from those, only 2 samples were positive. Sample 82, which gave 142 plaques, and sample 222, which gave 73 plaques. So then we carried out further analysis on the 2 positive samples to identify the strain. We did a restriction to nuclease PCR on the IS1311, and we were able to identify one of the samples as a cattle strain, and the other sample was surprisingly a sheep strain, which was persistent in cattle. So if we look a synopsis of our results, we were getting with the phage assay 96.9% positive for Mycobacteria, 22% positive for MAP. And for culture, MAP was present at only 0.9% of our samples, whereas the others were identified as negative, and this relates to the low sensitivity of culture I mentioned in the introduction. Now, because this test we did is based on an already commercial test, which is used mainly in third world countries, to developing countries, to detect tuberculosis in human sputum samples. And because they cannot do the PCR, they use the number of plaques as an indicator. So because we had all of this data, it was very important for us to see if we could apply the same principle to be able to differentiate positive and negative samples with relatively high sensitivity and specificity without having to do the PCR. So if we apply the 20 cutoff that the human TB tests has in our samples, we can see that 63% of our 63.4% of our samples gave less than 20 plaques, where 98% of our positive samples gave higher than 21 plus plaques. If then we rise this to 40, we double it, we see that this trade-off changes. The trade-off changes with 89.7% of our samples being negative, then they have equal or less than 40 PFU, and 92% of the samples have over 41 plaques. So the question here was, is there a relationship between the number of plaques and the MAP positive status of our samples? And is there a way we can process our data basically to end up with something which will be conclusive and can be applied in real life? If we go back to the basic distribution and the expected distribution of a screening test, the expected distribution of a screening test, the ideal, it will be like the one I have here. For example, we have the frequency against the test value here. We expect all of our negative samples to be less than the cutoff value we have, and all of the positive samples to be above that. And there is a clear area segregating them. In reality, this does not apply. Hence, we have, when we do all of the diagnostic tests, we have these false positive and false negative results. The reason is that the two distributions, in reality, they overlap. So you can basically move the cutoff. And if you move the cutoff, for example, and you want to be more sensitive, then you lose specificity. So which is the best way to determine the ideal sensitivity and specificity of a diagnostic test? If we plot our data looks like this. So it follows the trade-off we have seen earlier, with 40 plaques being in the middle. We can see here that the higher, for example, negative sample had 75 PFU, and the lowest positive has just 15. So the way to process and analyze the data, we decided to do a ROG analysis, receiver operating characteristic, which basically is a test which will give us a trade-off between the sensitivity and specificity. And we know, as I mentioned earlier, that any increase in the sensitivity will be accompanied, for example, by a decrease in specificity. So we want our curve to follow the left hand border as close as it can, and then the top border, then we will have a good and accurate diagnostic test. Another important measure here is the area under the curve, which is a measure for us to test accuracy. And we know, for example, that the area under the curves of 0.5 to 0.75 is a fair test. And ranging to 0.97 here to 1, which is the excellent, perfect diagnostic test. To give you an example to understand, if we had a diagnostic test with area under the curve of 0.5, it's like flipping a coin. It's best not to do the test, just flip a coin and decide basically if your sample is positive or negative. So we want to be as close as to 1 as positive as possible to have a reliable test result. So following the analysis from our data, we end up with a cutoff at 59 plaques. And we know that if we have our cutoff at 59 plaques, the sensitivity is 90% and the specificity is 99% with an area under the curve at 0.976, which is excellent. So we can apply this and we can have, we can predict in a way if a sample, the possibility of a sample being positive or negative without carrying the PCR. For us, it was very important to assess the reproducibility of the plague-forming units we are carrying out. So from 44 farms, we had an extra sample available, and which we also processed. And we got a very good Pearson correlation coefficient showing that our test is also can produce reproducible results. The other thing then was to try and compare the number of mycobacteria plague-forming units with the total viable count of the cell we were getting. So here we plotted this, and you can see the grouping of our samples, the positive and negative one. Here there was no significant relationship, which was interesting. So the probability basically of samples with low viable counts to have a low number of bacteria is the same as is for high viable count samples and vice versa, which means basically for us it's important. It shows that we cannot, the number of bacteria is not affected by any other contamination that we can have in the milk during the milking process. These results are published in the International Journal of Food Microbiology. Then we carried out a research in investigating the presence of MAP in powder infant milk-based formulas. And we optimized our phage assay for the detection of MAP in this very sensitive category of products. We did a small survey here in Cyprus using 32 commercially available samples. Phage PCR assay detected viable MAP in 13% of the samples, which was very important. Culture was able to detect MAP in 9% of the samples, and all these samples were also phage PCR positive. And we also did direct IS900 PCR, which detected DNA in 22% of our powder infant formula samples. Again, this is published in the International Journal of Food Microbiology. Now, the next step is to invest. We know that we can use phage to detect pathogens. Now, the next thing is to see if we can use phage to biologically control the pathogen. So we are currently carrying out experiments with the application of phage into spike, pasteurized, and UHT samples. We've optimized this. We did diluted UHT milk 10 to 100% to see if the milk affects the ability of the phage to bind to the host. We did different temperature treatments at 4, 25, and 37 degrees Celsius, because it's important if we can prove basically that we can put the phage and the phage will sanitize our sample, will destroy the pathogens, then it means that we will eliminate, we will take a step further to eliminating the pathogen from the human food chain. We have also trying different application times at 0, 30, 60, 90, 120 minutes etc. And so far we can say that we are pretty confident that we can destroy a number of 10 to the third map cells in 24 hours at 4 degrees centigrade. And for us it's very important because Cyprus is a country which is officially free from tuberculosis, and we know that the phage we have, it can infect also tuberculosis, and tuberculosis is a zoonotic disease and very important, especially in developing countries, and is something that again we are aiming to try and tackle and attempt to see if we can control the presence of tuberculosis in countries where tuberculosis, of course, is endemic. And we want, of course, to apply into naturally contaminated samples. We have paratuberculosis here in Cyprus, and we are getting samples from farms that are naturally contaminated. Colostrum is very important, and we tested against colostrum sample, which contains also a very high number of somatic cells to see if the phage infects and once it destroys the cells. Just to finalize, we were able to successfully apply the combined phage PCR assay we developed to bulk term milk samples. We show sufficient sensitivity despite the dilution we have. We are more sensitive and, of course, faster than the conventional culture method. We've showed a very good diagnostic reproducibility, and following the data analysis we did, we determined a cutoff at 59 plaques per 50 ml with a sensitivity of 90 and specificity of 99% for predicting the presence of MAP in milk samples without having to do the PCR after. We also applied it in power infant formulas, and the potential application for biological control. This is very important for us. It's very important always to explore new ways of processing our data, because this part, which is also very applied, it means that we collect a lot of data. So we are trying to also find the best ways and the best tools to analyze this data in accordance always with the logic of the biological sciences. Thank you all for your attention. Of course, this is a team of people in our lab who are working with this, and a lot of other institutes who are working abroad. I don't know if anyone has any questions.
Thank you, George. Please, the audience is free to make any question that may have. Okay, George, thank you very much. Your presentation was quite interesting, and due to the public health is rely on that, and it's very critical for everybody, as I understand. You expressed some concerns at the beginning of your presentation about the direction of the topic, but as I am sure that you know that every research activity, every human activity that produce such kind of data that can help one to make predictions, to make decisions,
yes,
to monitor, and it's very useful, and you can find the large common ground of cooperation with our project area of topics.
yes.
And as I said, I can see a large common ground of cooperation, and I can express our willingness and readiness to cooperate,
Yes.
On that.
I am here, very happy to hear this, and I'm sure there are new ways and even more adventurous ways to process our data and end up with more meaningful conclusions.
That will be great. Thank you very much once again. Thank you very much.
Thanks.
Okay, and with the last and with this presentation, we have we can conclude the day. This is the end of the third day of the school. I remind you that tomorrow we have the fourth day, and we will start again at 9 o'clock at the EE time, Eastern European time. And I kindly ask you everybody to attend all the interesting presentations of our school. Thank you very much for attending this school today, and I hope you are enjoying the presentation.